Hello. In lesson 5, we talked about the Pascal's triangle, where we used it to find coefficients of expansion of binomial-related problems. But there is another way we can find still those coefficients, and this other way is the binomial coefficient formula, this one. So the logic of this formula is basically, it asks us how many ways can we choose k objects from n objects, in the sense that n represents the total number of items we do have, then k represents the items we want to choose from the total number of items we have. So for example, if I have 3 fruits, let's say, and then I give n is equals to 3, meaning I have total number of fruits 3, then I want to choose 2 fruits from these 3 fruits. So that binomial coefficient formula will help me understand how many ways can I choose 2 fruits from 3 in no particular order. And the reason why you hear me insist about order is because there is another formula for permutation where order matters. But in this one, order doesn't matter. So, the formula is given by n, choose k, meaning the total number of items I have, then the ones I want to choose from the total, which is equals to n factorial. If you don't know the logic of factorial, you can review my previous lessons. There is a place I've talked about factorial, and then divided by k factorial into n minus k factorial. Like that. This is the formula. Where n, we said, represents the total number of items we have, and then k is the items we want to choose from the 3, and then the whole logic is how many ways can I choose these 2 items from these 3 in no particular order. So if we do this one, we replace the values in the formula, it will become 3 factorial, because the total number of items we have are 3, divided by k factorial, but k is 2, so 2 factorial, into n, which is 3, minus 2, which is k now factorial, which now will become 3 factorial divided by 2 factorial into 3 minus 2 is 1, so 1 factorial. So the logic of factorial is just take this number and multiply with all the numbers below it up to 1. Then I divide by, I do the same for 2 by 1. All the numbers below 2 are just 1. And then again, I multiply again by 1 factorial, and all the numbers below 1 is just 1. So it will remain to be 1. So which becomes 3 by 2 by 1, which is 6, divided by 2 by 1, which is 2, and then the answer becomes 3. So I can choose 2 fruits from the total number of fruits, which are 3, in 3 different ways. So putting this now in a real life situation, can I show you? If I have 3 fruits, which is apple, banana, and cherry, and I want to pick 2 from these 3, the number of ways, of course, we said we can pick is 3 into 2, which is 3 ways. So in these 3 ways, what I mean is I can decide to pick an apple and a banana. That is the first pick. Then again, pick an apple and cherry. That is the second pick. And I can also pick a banana and cherry. That is the third pick. So I can combine these fruits in 3 different ways and then pick. That's why we say we can pick 2 fruits from the 3 in 3 different ways. So that's the logic of the binomial coefficient formula. So now that we know the logic, can we use it to solve some problems here? For example, can we try to solve 5 choose 2? In this sense, if I put it in a real life situation, I can say pick 2 fruits from total of 5 fruits. And as we know, our formula is given by n choose k, which is n factorial divided by k factorial into n minus k factorial. But now in our case, n now is 5 and k is 2. So we are told to pick 2 fruits from the 5, which is now given by 5 factorial all over k factorial, which is 2, into 5 minus 2, but now factorial, which becomes 5 factorial is the same as 5 by 4 by 3 by 2 by 1 divided by 2 factorial, which is 2 by 1, then multiplied by 5 minus 2 is 3, so 3 factorial. So 3 factorial will be 3 by 2 by 1. So if I cancel this one with this one, I cancel this one with this one, then by 2 1 by 2 2, so it becomes 5 by 2, which is 10. So I can pick 2 fruits from the total number of fruits, which were 5, in 10 different ways. Can we try another example? How many ways can we pick 3 fruits from a total of 6 fruits? So our n now becomes 6 and our k becomes 3. Right? Yeah, I think that was the question. Yes, 6, 3. So becomes 6 choose 3, which is equals to n factorial, of course, is 6 factorial, into k factorial, which is now 3 factorial, into 6 minus 3, but now factorial. I'm following the formula here. So this becomes 6 factorial into 3 factorial, but now 6 minus 3 is also 3, so 3 factorial. So I want to show you another similar way of cancelling these numbers. So first, if I have 6 factorial, I can just say it is 6 by 5 by 4, but then by 3 factorial. Why? Because here, even if I continue with this 3 factorial, I can say it is by 2 by 1. It's okay. But you see, I already have another 3 factorial here. So instead of continuing here, why can't I just divide by this 3 factorial like this, then again by the other 3 factorial, and then just cancel 1 3 factorial here with 1 3 factorial there, and then just remain with 1 3 factorial just down here. So now the answer remains to be 6 by 5 by 4 divided by, but I know 3 factorial is the same as 3 by 2 by 1, which is 3 by 2 is 6, 6 by 1 is 6. So I put 6 there, and then I cancel this 6 by this 6, and then I remain with 5 by 4, which is 20. So I can choose 3 fruits from 6 in 20 different ways in no particular order. So can we try the last example? How can we choose 4 fruits from 7? How many ways can we do that? So if we go back to our board, the question now is n is 7 and then k is 4. So as usual, our formula applies where we have 7 choose 4, which is equals to n factorial, but now we know n is 7, so 7 factorial divided by k factorial, which is 4, into n, which is 7, minus 4, but now factorial. So it becomes 7 factorial into 4 factorial into 7 minus 4 is 3. So 3 factorial. So I can do this 7 by 6 by 5 by 4, but now 4 factorial, because I also have a 4 factorial here, so that I can cancel this 4 factorial with this factorial. So divided by 4 factorial into 3 factorial, and I cancel this one with this one, so I remain with 3 factorial. So it becomes 7 by 6 by 5, but now divided by 3 factorial. But 3 factorial is 3 by 2, which is 6, 6 by 1, which is 6. So I put 6 here, and I can cancel this 6 by this 6, and then I remain with 7 by 5, which is 35. So I can choose 4 fruits from 7 in that 5 different ways. So this is the logic of that binomial expansion formula here. Thank you for watching. You can subscribe to my channel for more of this content, and you can also like, share to other students so that they can understand this logic. Bye for now. Let's meet in the next lesson.